let's take another look on the thing. So now we have the now we can basically make projects and compile them and put those in the processor. So great, and we can even have a debugging there. You just use that LCD there to print out on different kind of parts of the code wherever you need print out. You just use the LCD module for now. Okay, couple of other things you need today. Let me go and I could use the other computer now. Just a second, since I need to take a closer look at all right, so the first exercise, I need to take a closer look. No, of course. When I turn that computer on, I lose the signal from this. Oh, great. There. Just checking what you need to do. So LED. Okay. So I need to scribble something. Well, actually, it's right there. Now, pay attention, since in 1 hour you will ask me questions that are directly from that chapter there. What is digital output in PSOC? Any digital output, where you want to have software control. That's called LED module. It doesn't need to be the same name on your program, but the module is LED. So if you want to, for example, have a simple on-off control of anything, so basically, say you have a transistor like that, and then you have a big motor here, okay, at high power, and you want to control that. You would have the PSOC circuit, and then, for example, signal name, gate, but inside of here you would use LED module. Okay, so any signal you want to get out from software is called LED. All right, so let's go to the PSOC designer again, and there the miscellaneous digital LED, there, LED pin. You need to just define 3 things: which port, let's see, on the exercise that would be port, it doesn't actually have any description, but basically any port for example, port 1. Port 2 you cannot use since the LCD is there. So port 1, for example, pin 6. And if it's active low or active high. Okay. If you are running, for example, this kind of signal, I would put it, active high, yeah, active high signal. So basically, when you run this one high, then it basically, turns on the transistor. Okay, active high, and again, it doesn't require any digital blocks, and that's basically what you need to do. And if you want to see what are the parameters and that kind of things, let's see, I will show that one in different window, separate window. Well, not LCD, LED. That sheet, separate window. There we go. So basically, those are the two different purposes how to use that one. And then we have this API, and then simple code. Okay, LED start. So any module you put on your design, you will start the module. So that makes all the initialization of the port. For example, here, what LED start does, it configures the output as strong output, meaning it can both push and pull high currents, up to 4 milliamps, guaranteed. So this output actually can be in 8 different modes. So that's basically helps you defining the output. Okay, and then it's a LED switch, either on or off, and then there let's see what functions. It has LED on, LED off, LED invert, LED get state. Okay, all the required functions or atomic functions to control the LED. Or if you have a signal named gate, I would probably want to have the same name here, gate. But it's up to you how to name them. As long as you now use the same thing on your program, so let me generate. So on the main function, you would have something, and it already shows you what kind of functions they are. Okay, for example, start. That's a function. Yeah, and so on. Okay. Next, let's see here, exercise. All right, pin input. Pin input is a little bit different. Basically, you can define any input as digital input. I'll show you a couple of tricks how to do it. So basically, it's also in the technical reference manual, chapter 6, meaning general purpose I/O, everything, but this is just a shortcut how to do it. I'll just show you it briefly. Okay, for example, if we want a pin somewhere in there, let's see. Hey, port 0.2 sounds like a good pin. Okay. We can rename it here, for example, as button, meaning that this, okay. there is a push button. Like this, which connects into PSOC. Okay. Oh wow, I made a big kind of thing here. Okay. PSOC pin something. All right. So that would be 5 volts. Something is missing here, of course. You know that you need to pull if you have this kind of, you know, the signal that goes. You just turn it to +5. You need also, oops, not short circuit, but you need a DC way to ground, right? That will be just legitimate connection. However, you can always use the internal pull down resistor. Okay, in this case, you wouldn't need the external. And you would do it like this. So yeah, port 0.2 would be called button. Button, there. And that's standard CPU, meaning that it's just a normal signal going to registers that this MCU is actually reading. And then there's the drive. All right, 8 different drive modes. And I want pull down mode. There. Drive is pull down. Oh, well, it's up to you. I selected port, I actually selected port 02. That port 1.6 is the output. But you can choose your own favorite port and pin. So this is in my example 1.6, and this is in my example 0.2. We'll leave the interrupts for tomorrow. Okay? Any objections? Initial value means that when you have these the system started, what is the after start, what is the state of that port? And initial values of 0, it's good. Okay. For pull down. If you put it pull up, then you would probably have initial value of 1. There. Okay. Let's generate the configuration files, since now we actually need to go and take a closer look at one of those header files. PSOC GPIOint.h has all the information what you have changed from the default names. For example, that pin, it should appear here. Nice. There are macros, macro definitions for button, defined as IO port. That's the variable, which is 8 bits, which is byte. Do you know what the pragmas are? Pragma is a compiler directive saying that, okay, you should consider, the compiler should consider that that variable as IO port. It's register controlled IO port. All right, so basically, button data ADDR is your access point to the data. 8-bit data, but this is just 1 bit. Then there's the mask, a lot of other things, but where's the mask data ADDR and oh, there. Oops. Mask. Oh, there. Button mask. Number 4, binary. Okay. Okay. That's basically pin 0, 1, 2. The mask means actually that, nothing else. You can, if you want to, also read other port pins. You just need to define one port and then basically have different masks for each bits. And basically when you are reading this port pin state, you would basically do it so that you have the, well, I will just write the code. Oops, main. Okay, how to access. So you have the button, oops, data ADDR. That itself gives the value of that port. Equals to, not equals. You actually put the AND operation. Bitwise AND, single ampersand. And button mask. That gives you the state if it's true or false. And the numeric value of true is 4. Or anything else except 0. In C programming language, false means 0, true means anything else. Right. So basically this actually can be used on if statement, just like that. So if the button is pressed, that value is true. Oops. There. And of course, let's see. After compiling, well, this will give me a error because, well, I should have some. Hey, I could actually move that one here. Yeehaw! Now I have some code there. Ha. Good. So basically, that basically there's just checks if the button is pressed or if there is true value on port 02. And if it's true, then it just prints that string. Meaning? No, it's single. If it's a single line, then it's single line. Then you can do it that way. Otherwise, if it's several lines, then you put it in brackets. Yeah. Yep. Basically, good style would be to use always the brackets. Yeah, that would be good style. Okay, so that was how you read a pin. And of course, let's see, next part. That was the LCD display, and then, oh wow! Basically, now you should be able to do the first exercise. However, I would like to give you a couple of pointers here. First of all, if you read the exercise, the description, on the top you should put your name, date, and whatever I asked there. So remember to claim your code. If you have more than one, put all the names there. Okay? And the other stuff. What did I actually ask there? Commented error with the description. Description, author, date, and course ID. Yep. Put those there. And you know how to make the longer the comment area, right? Like that. / star and end it with the star / oops. Like that. So now I can put the description here. John, author, date, and the course ID was PSOC. Oops, design. Another thing, when you're making embedded code, this one here, especially for small program the systems, you need to have operating system. My favorite operating system is while one loop. Okay, the main execution loop. Don't let it, run into the point that there's nowhere to go. Since a processor will keep processing whatever the code you have there. Usually it's basically a block of zeros there, which is commonly used as no operation. But after that 4 kilos of no operation, it will go to some boot code again. And it can actually start doing erratical things. So basically, put at the end always while loop. So while one loop should be somewhere on your code. That's the main execution loop. I think it was tomorrow when we talk about interrupts. Okay, I'll show you how to actually do things. So since this is the main execution loop, and what should be done there is the execution. Most of the code should be called from that loop, and then the interrupt should be as short as possible. But that's tomorrow's topic. What else? Yeah. Although the C compilers usually they tolerate, almost anything nowadays, but please keep the code tidy. So on the beginning of your main or any function, you have the variables section, local variables. All right. And then somewhere here you have the code, or basically then you have the initialization section. And then you would have the, say, the code before going to the while loop. Make kind of blocks of code kind of going, which is easy to read. I don't want macaroni and cheese. I want code. I have been producing enough of the macaroni and cheese myself. Have you heard of programming language called Fortran? Okay, that's macaroni and cheese. Okay. Still used, by the way, the Fortran. Massively parallel computers. The most efficient programming language is actually still Fortran for some weird reason. All right, so yeah, that will be almost, say, almost a acceptable code. Not quite, but almost. Okay, so that's the first trick. Try to make that one easy to read. And then, let's see, compile it. Does it? Oops, this. Description. There. All right, so let me copy that one. Now, the other part. How to make a link to a document that I can comment your code. Well, go to your Google Drive. Let's see, I might actually put it somewhere. And any one of your directories, you would actually just make new Google Doc. Name it correctly. For example, code for example 1, and maybe some author and that kind of stuff in here. That's fine. Then you would have the code here. Let's see. Maybe paste without formatting. And then this is just my way of doing it. I like to read Courier font. I don't know about you, but I'm an old guy. I like Courier on for the code. Okay, but it's up to you. You can, well, oops. You can always just leave it like that. Also, although it does not look good code for my eye. So maybe changing some, Courier or other constant with the character code. Okay, maybe smaller font. Yeah, a little bit maybe. And then, most importantly, sharing is caring. Advanced sharing options. Anyone with the link can comment. There. Got it? So make a Google Doc. Make a link to your the answer, and then just save it. And that link is the answer to link to your code on the exercise return sheet. If you hate long ones, basically then you can, well, totally up to you. goo.gl. Oops, not that one. Google Docs. Ah, not that one. Oops. Your code. That's your link. Right there. And let's see again. If you want shorter URLs, use goo.gl or some other shortener. Okay, anyways, that's the code. All right. And then, okay, another thing, when you are done with these files or design, to your directory. And in my case, I think it's under well, where are these things? Documents? Yes. Designer projects? Yes, that one. Okay, find your design directory. Zip it. Okay, there's a zip file. Move that to your favorite I use Google Docs. Oh, the Google Drive there. Uploading. Less than a minute left. Done. Okay, now it's there online for myself. Share. Advanced share. Anyone with the link can view. There. Okay. So now when you go to the end of this page, link to exercise return form. Now you have something to return. So your email address, home institute, name. So if you're working together, just one return is fine. Link to Google code. Okay, the code was here, so that's the link. No, that one. No, that one. Yes. There, that's the link, right? Don't worry if they are long. Computers can handle. Link to piece of project. That will be here. That link. Oops. That. There. And okay, how do you remember that you actually submit the exercise? Send me a copy of the. So that's how easy it is. So let's just click submit, and now I can get hold to those files what you sent me anywhere, anytime. Yes, just the links. No files, just the links. You put the files on cloud service, preferably Google. Actually, yes, Google, since you cannot actually easily comment. Hey, wait a minute. Maybe there is some other tools. So basically, the most important thing is when I go to, I'll show you why I'm asking it that way. If I open this results on my Google Drive, so you actually see this one as a scoreboard. Let me show you. In here at home, down here, there's a scoreboard. That's the web link to the this whatever you are doing. like now, you can see the attendance on exercise 1. Okay. So basically, when I go here and take a look at the exercise returns, see, there's for me only a couple of things to click. If I click on the own code, I can immediately go there, start commenting it. That's why I'm asking it as a Google document, not C file. C file I can only open, then edit, then put it somewhere. No, it doesn't work. Okay, but this allows, you know, commenting like this. Okay, I know, I watch too much TV. Yep, same thing. Okay, and then the link to the PSOC project file, the zip project file. Okay, what I can do with that one, I can download it, unzip it, and then try on my own board. Just the link, zip file. Remember to put your zip file on some cloud service. If it's on a local computer, it doesn't work. Just, you know, why am I telling you this? Every single time I have a course, there will be some files which are on C something. Okay, hopefully this time no. Nobody makes that simple mistake. All right, and what else? Yeah. And then when I have happy with the assessment, I go to the scoreboard. Let me, for example, put here one more name. Where is the insert one? 32. When I'm happy with that one, I can give you 10 points. If I'm happy. Okay. How to get 9 points? Link does not open at all. It automatically reduces the points, even if you get it right the next time. If I cannot check it, it's 0. Okay. The other one to lose 1 point is I cannot comment it. So make sure that when you have the code here, it says anyone who has the link can comment. If it says anyone who has the link can view, then you lost 1 point.